All right, back. Yes, good morning. Good morning, good morning, good morning. Good morning. Hola. Guten Tag. Buenos dias. I think that's all the different languages I know. What's French? French? Au revoir. Au revoir. Hawaiian. Aloha. All right, welcome. Welcome to math class. So, wrapping up scientific notation. Hopefully, man, it's like beating a dead horse. We've been on this for a couple days. But I told you I was going to take it slow, all right? So hopefully we're taking it slow. I know we need to practice, when we are practicing. But this stuff will never go away, We gotta remember this till May. So anyhow, last thing we're going to do is put them in order. All right, you can order numbers from least to greatest or greatest to least, right? So when you see a problem on a test or a quiz or on the computer and you have a highlight tool, if you were in my class, I would have you underline the directions. 7th graders, for some reason, have trouble remembering. If I've got 2 questions in a row, the first question says, order these from least to greatest. And the student does it perfectly, right? Let's say the whole class does. The second question says, order these from greatest to least, which is opposite. I'll have half the class still put them from smallest to biggest, least to greatest, because they just think the questions are all the same. So always remember what the question is asking you. So let's jump right in here. Here we have 3 numbers in scientific notation. The first number is between 1 and 10. That's close to 10, but it's between 1 and 10. Bigger than 1 and less than 10. And it's times 10 to some power, right? These are all big numbers, right? Because they're positive exponents. Positive, they're all big numbers. So the directions, let's say, order from least to greatest. Alright, there is a very easy way to do this. Very easy way to do this problem. Now, I'm going to have some of you do it the hard way, right? The hard way would be going like, all right, 1.78 times 10 to the 8th. I've got to move that decimal 8 places, so this turns into 1, and then the 7 takes up 1 spot. So 1, 2, 3, 4, 5, 6, 7, 8. So that's that number, 170 million. Guys, don't do it. 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 You don't need to do it, all right? You don't need to do it. First thing we want to look at when we're ordering is the exponents. The one with the biggest exponent is the biggest number. This is an easy problem. The smallest one here, look, I kind of did it to trick you. You don't even look at these first numbers, 6.2, 9.99, 1.7. First thing you look at is the exponent. I put 9.99 there because it looks like it's a big number, bigger than, look, this is a little old 1, right? But this number is actually the smallest because the exponent is 2, right? This number, if we changed it to standard form, is only 999. Move the decimal 2 places, right? This number is 170 million. Look at the exponent. So the first number, ordering from least to greatest, would be 9.99 times 10 squared. Anything to the second power is called squared. So that one's gone. Now we look at the exponent. This has a 3. This has an 8. This is definitely the smallest. If I changed it, move the decimal 3 places and make it bigger, 200, 6,200. So 999, 6,200, or 170 million, right? So the next one was going to be this, 6.2 times 10 cubed. Anything to the third power is called cubed. All right? Cubed. And then, of course, the biggest one is this, 1.7 times 10 to the 8th power. Look at the exponents, guys. Look at the exponents, all right? I'm going to try to erase this real quick, and we'll do one more here. Do one more. My whiteboard doesn't want to erase. This is horrible. I've got the worst whiteboard on earth. So bear with me in that route, but I'll write slow. Got it basically clean. I got to use a cleaner almost every time, and it's taking the film off of it, I guess. So All right, 3 more. Let's give you some more. Let's do 5.1 times 10 to the negative 3. Let's do 4.7 times 10 to the first power. And we'll do 3.2 times 10 to the negative 3. All right? All right? So, what do we do when we're ordering? First thing you look at is the exponent. We got, oh, let's put the directions down, I guess. We will order from least to greatest. Order from least to greatest. All right? So this one, if we're looking for the smallest one, we just look at the exponents. We got a negative 3, a 1, and a negative 3. Well, this is definitely the biggest number. These two are negative, right? Doesn't mean these are negative numbers, just means they're little bitty numbers. This is a big number, right? So I know this is going to be the greatest. This is going to be all the way on the right. These two, however, we got a problem now. If the exponents are tied, they're tied, how are we going to figure out which one is the smallest? Right? Well, then we do have to go, if these are tied, the negative 3 and the negative 3 are tied, we've got to go look at the first number, right? And then which one is smallest, right? 3 is smaller than 5. That's the only numbers we got to look at. 3 is smaller than 5. So this is the smallest number. 3.2 times 10 to the negative 3. Then we would have this one, 5.1 times 10 to the negative 3. And the biggest, 4.7 times 10 to the first power. Look at the exponents. Don't be doing them all out. You don't have to make this. This would be 47. This one would be 3 zeros and a 32. Put the decimal between the first. This would be 3 zeros and a 51. Put the decimal between the first two. 51 is bigger than 32, right? That's why this one is first. Then this one, then this one. Alright, least to greatest. You don't have to do this part though, guys. Make it easy. Just look at the exponents when we're ordering them from least to greatest. Look at the exponents. Read your directions. Sometimes it might say greatest to least. Alright? I bet on my warm-up tomorrow or the next day or so, I'm going to switch it up for you. So you better make sure you read the directions. Alright. Ordering. Scientific notation. Least to greatest, greatest to least. Until next time in Video Land. Peace out, Girl Scouts.